Good morning to all. My presentation topic is a review on the application of biopolymer in food grade packaging. The review paper shows the summary of application of different biopolymers in packaging. Today I will be talking initially about the protein based polymers, then about the polysaccharide based polymers, and lastly about the biopolymers derived from petroleum based. Yesterday, the important factors related to the need of replacement of single-use plastic was already talked. So my presentation will just supplement with some new information. The conference yesterday started with a very good presentation from Professor Gaikwad, and the all others followed it. The main outcome of that session was that it is important for paper to become a good packaging material if its barrier properties are enhanced. So basically, packaging just is used to contain, preserve and protect a product. The innate property of paper are not very good in terms of barrier because of its heterogeneous nature. To enhance the barrier properties of paper, it is normally coated or laminated with different petroleum-based biopolymers, but because of that, there is a degradation in the repulpability or recyclability of the paper. The solution for this is if we have a coating material which is water soluble, so that even after application, the recyclability and repulpability of the packaging grade paper is not reduced, it is maintained. A lecture by Professor Dharamdat was given on this yesterday. He touched this point also. Now the global packaging market is expected to grow at a CAGR of around 5% from 2023 to 2032. But the good thing for us is that the Indian packaging, food packaging and beverages market is going to grow at a CAGR of almost around 15% in next 6 years. So when we compare India with rest of the world, we have an opportunity of around 3 times in the packaging grade market. Not only the paper market, when we see the potential of India in terms of biopolymer use for the packaging, it will be around 25% CAGR. The bioplastic market in India will grow at around 25% in coming years. Now, basically, biopolymers are characterized in 4 types. The first one is which is derived from the extracted biomass. In this, there is polysaccharide based, protein based, and lipids. In polysaccharide, there are starch, cellulose, chitosan, and other. In protein based, it can be collagen, gums, whey protein, and the other is the biopolymers which are derived from bio-based monomers. This includes polylactic acid. Yesterday, the polylactic acid application in paper cup coating was also discussed. And then the other one is polyolefins. And the other one, we can have biopolymers which can be derived from microbial way. It can be polyhydroxyalkanoates and bacterial cellulose. And the other one is biopolymer can also be made from the monomer derived from the petroleum based industry. Now starting with protein based polymer, this part of the application of protein based biopolymers was not touched yesterday, so this is new. In this we see that gluten, why we can use protein based polymers, because there is a good film forming nature. They have inherent better barrier properties in terms of oxygen, and water vapor. Gluten gluten is one of the protein. It is also having excellent gas barrier property. And then whey protein offers good oxygen barrier properties and making it ideal biopolymer. The combination of organically modified clay with soy protein offers double advantage of thermal stability and reduce oxygen barrier property. Now this is some example. When we have a substrate here, paper and paperboard. It can be either paper or paperboard, and when we apply different protein based biopolymers on that, you can clearly see that it reduces the different barrier properties. When wheat gluten alone is used, it reduces the oxygen permeability. When whey protein is used along with glycerol as a cross linker, it increases the paper resistance to oil without significantly degrading its strength properties. When we use core gene alone, grease resistance of the core gene coated paper is almost comparable with that of polyethylene laminate. So that can be one of the solution. And when core gene by another researcher, it also shows similar results. So core gene is something on which we can have good research further, and it can be applied in the industries. Now, hello, am I audible? Now coming to starch. In paper industry, mostly we use starch. We use starch in paper industry. Mostly modified starch in name as oxidized starch is used. The oxidized starch is used and it improves the strength properties, but not all the barrier properties are enhanced which are required for the paper industry. Now if we can modify starch by adding certain biopolymers or certain nanoparticles, we can improve the quality of starch, and we can apply the same starch with the standard surface sizing technology, so that the properties of barrier which we want can be achieved by the paper industry. The other thing which we can do, we can blend this starch with, as I have already told about protein based polymer. When we will blend both of them, or we do layer by layer coating, then we can increase the mechanical as well as the barrier properties of the paper. The other polysaccharide based polymer is chitosan. The structure of chitosan is almost similar to that of cellulose. The only difference is that in place of hydroxyl group there is amine group. Now when we will use this chitosan in surface sizing, it will provide both hydrogen bonding as well as covalent bonding because of the presence of NH2 group. So here are different research which has been done. The chitosan is having molecular weight, different molecular weight and different degree of deacetylation, and accordingly it can be applied in surface sizing of paper. It works good in terms of barrier as well as in terms of mechanical properties. Now this can also be blended either with starch or with protein based polymers, and further we can do this by layer or by blending these chemicals, and it can further enhance and give us properties which are required. Now this was yesterday discussed by one of the fellow speakers from TNPL about the PLA. So PLA is a synthetic aliphatic polyester, but it can be used in paper coating and surface sizing. Now which are the constraints which are there with PLA? They can also be modified. We can modify PLA. First of all, we will modify PLA. We will put the properties which are required in the paper. In the paper, we will modify PLA accordingly by adding different nanomaterials, different biopolymers, and when we will get, so for example here we have reduced the after adding organic clay. Clay is used in paper making also. It is available within they can modify it themselves, and they can get a PLA with reduced OTR and WVTR around 50%. Then they can use this with in paper making, in surface sizing of paper. Now the cost factor which is there, the cost factor, suppose PLA is very costly, but if starch, oxidized starch we all use, if we can blend 5 to 10% of protein based or PLA or chitosan along with oxidized starch, if we work, then this can come as an effective solution to the paper industry, and the properties which are required in paper to make it a better packaging grade material can be achieved. So finally, as a conclusion is biopolymers, because there are a lot of biopolymers, but those which I have covered, they can act as a good solution to the paper industry. The cost is higher, but by blending with starch, we can reduce this limitation and we can have a better solution with biopolymers. Thank you.